In order to introduce virtualization, I first want to talk about a stack. Essentially, a stack represents a combination of infrastructure, an operating system, and all the applications that you might install on that server that are required to support some sort of service. So you can think of a stack as being these three different layers of technologies. Now, before the early 2000s, you would typically install one stack on one physical server. So you'd have a physical server with CPU, storage, networking, memory, etc. And on that server, you would install your operating system of choice. It could be Linux or Unix or Windows. And then you would install your software applications. You could only install one operating system and one set of applications on that physical server. So that's what we call a stack. Now, with virtualization technologies, we can basically create software that emulates hardware. What does that mean? Well, what that means is that we can essentially simulate multiple physical computer servers on one computer server. So we can take a single server and partition it virtually and run and operate it as if it were multiple servers. And each virtual server that's running on the physical server can contain its own stack, its own operating system and set of applications. And these multiple stacks are logically partitioned in terms of the CPU processes, the memory, and the networking. So essentially, you're simulating multiple servers on one physical server. And virtualization technology solves a lot of different problems. I can remember in the late 90s where, if you wanted to deploy different types of applications, you would generally have to buy a separate physical server for every application stack. You might have two different applications that required a different version of the same database, and there was no way to run the same database, or multiple copies of the same database on the same physical system. And so it became really expensive years ago to run application stacks because it required a physical server for every stack. So virtualization solved a lot of problems for us. It basically turned hardware into software. It made it easy for us to maintain virtual servers and move them around from one system to another. We also, no longer had to buy as many physical servers. We could partition a physical server into multiple virtual servers and then install a separate application stack in each virtual server and provide each team within our organization with their own separate virtualized server. So it was very convenient. Now, when we look at virtualization technologies, you need to understand a couple basic definitions. First of all, we have the host machine. The host machine is essentially the physical server that is supporting multiple virtual machines. So, virtualization always requires some sort of physical hardware that is supporting the virtual machines, and that's what we call the host machine. And then we have the virtual machine. The virtual machine is that virtualized server instance. It's that simulated server that's running in software. And that's running on the host machine. Sometimes we call it a virtual instance, or sometimes you might hear me call it a workload. The host operating system is the operating system that is installed on the physical server. Sometimes it's also called the bare metal server. And then the guest operating system is the operating system that's running in a virtual machine. You'll have a host operating system that has some sort of OS, and that host operating system is going to be running and supporting one or more virtual machines, each of which has its own guest operating system. And those guest operating systems, in some cases, could be completely different. And then finally, we have the hypervisor. And the hypervisor is a piece of software that is really handling the emulation of the virtual machine. It's managing the communication between virtual machines and the physical server. There are a couple different types of virtualization that you need to be aware of. The first is what we call hardware virtualization. And with hardware virtualization, you can think of this as being sort of a way of partitioning a physical server into smaller physical servers, each of which is a sort of its own independent hardware server. Typically, you see this sort of hardware virtualization in something like really big mainframe type systems. Like you have like these massive IBM mainframe systems that essentially have, in some cases, hundreds of physical servers that are located within this larger mainframe chassis. And the mainframe system has the ability to allocate and quickly sort of initialize these individual physical servers and make them available to users of the system. And so in this case, it's the virtualization isn't happening so much in software. It's just that the mainframe has the ability to carve out sort of a small piece of itself and provide it to a user and expose it as a server. The second type of virtualization is what we call software virtualization. And this is probably the most common type of virtualization in the marketplace. And there's two different types of software virtualization. There are what we call type 1 hypervisors and type 2 hypervisors. Now, type 1 hypervisors run on top of the bare metal server. So there's that hypervisor software. You can think of the hypervisor software as acting like an operating system. It's installed directly on the physical server, and then the virtual machines are running essentially on top of the hypervisor. Examples of this include VMware software like VMware ESX and the Xen hypervisor that's running on Linux systems. Then type 2 hypervisors actually run on top of an operating system. So you could have a physical server, you install something like Linux, or you install Windows on that server, and then you install a hypervisor software application on that operating system, something like Oracle's VirtualBox or VMware Fusion. And then those hypervisor software applications are able to create virtual machines. And so the distinction is that type 1 hypervisors run directly on the physical server, directly in bare metal. Type 2 hypervisors run on a traditional operating system like Windows or Linux. And here's a diagram just giving you kind of a quick pictorial explanation of how these things work. Again, type 1 hypervisor is installed directly on the hardware, and then virtual machines are created by that hypervisor. Type 2 hypervisors are just like ordinary software applications in a way. They run on top of the native operating system. They can run alongside other applications. And then the type 2 hypervisors allow you to create virtual machines that are sort of running on top of the hypervisor and also running on top of the native operating system. You might have already surmised that type 2 hypervisors are generally a little bit slower because they have the additional overhead of the running on top of a native operating system, versus type 1 hypervisors are running directly on bare metal, so they tend to be more performant. Okay, so a third type of virtualization that we'll look at in this course is something called OS partitioning. And we'll actually spend quite a bit of time looking at OS partitioning later on in the course. With OS partitioning, you have a server with a host operating system, something like maybe Linux, and that operating system is able to partition out processes, memory, and the scheduling of CPU, and it's able to carve out sort of processes that look like and act like separate operating system environments. They're not actually separate virtual machines in a traditional sense. These are like super processes, as we'll discover later in the class. The key distinction with OS partitioning versus the software virtualization we looked at previously is that in an OS partitioning environment, all of the sort of virtual environments will share the same operating system kernel. If the host operating system is Linux, then all the guest operating systems will also be Linux because they're actually all sharing the same exact operating system kernel. So in a way, these aren't acting like virtual machines because like software virtualization, virtual machines, and each virtual machine could have a completely different operating system. But that's not the case with OS partitioning. Every virtual environment shares the same operating system and the same kernel. And probably the most popular technology today that's implementing OS partitioning is Docker in the form of Docker containers, which we'll look at later on in detail in this course. Now, virtualization has basically taken over enterprise infrastructure. If you walk into most any enterprise today, you'll find that almost all of the application workloads have been virtualized. And the research firm Gartner estimates that at least 75% of workloads are virtualized. And this statistic is probably several years old now. So I wouldn't be surprised if more than 80% up to 90% of workloads were virtualized today. In fact, it's pretty rare to find a workload which hasn't been virtualized. And those are typically legacy applications or maybe certain types of databases that cannot easily be virtualized. One thing to note, and this is something I learned about a year ago, was that new virtualization licenses have begun to decline. So companies like VMware now are reporting that enterprises are no longer licensing virtualization software as much as they did in the past. And that's kind of a massive change. And I think probably the key reason for that is because many of the new application workloads are moving to cloud providers like Amazon.